Hello everyone, a very good afternoon to each and everyone out there and welcome you all to this amazing platform of PW English class 9th and 10th and to your Phoenix batch. As we are doing one shots of all the chapters from your NCERT along with the syllabus that is there in your CBSE curriculum. So here now we are going to do the chapter statistics in one single shot. So basically what statistic hold is only your starting with bar graph, histogram, frequency, polygon, right? But of course there are some boards in which mean, median and mode is also coming, but we have to follow CBSE. So we will be doing a quick, a detailed explanation of the first three, that means bar graph, histogram, frequency, how to draw the tally marks and all that, how to draw the frequency distribution table, along with a brief like summary of mean, median and mode, that is central tendency as well. Though it is not in CBSE, but of course as there might be students who are from different boards, so that might help them. So let's start with the very first thing that we are going to do is, let's start with what we are going to do, that is today's target. So we are going to start with the introduction, of course, collection of data, that what is statistics and what importance does it hold in day-to-day life, that is something that we are going to do. Presentation of data, bar graph, histogram and frequency polygon. So these are the three things that are there in your syllabus. But apart from these three things, we also have central tendency, that is mean, median and mode. So we will be having a quick recap of that as well. So let's start with the very first thing, that is what is statistics. Why is it included in maths and how is it useful? So the present day society is essentially information oriented, of course. If I have to ask you people that who is your favorite cricketer, do comment it down, right? If I ask you people who is your favorite cricketer, some of you will say ma'am Rohit Sharma, some of you will say Virat Kohli, some of you will say Thala for a reason, Mahendra Singh Dhoni, some of you will say Surya Kumar Yadav, Hardik Pandya, KL Rahul and whatnot, right? So of course this is also a data. So what does statistics deal with is collection of that data, and after collecting that data, presenting it in such a way that other people can use the information, see it and grab some knowledge. So this is what single-handedly thing is about of presentation of data. So when we talk about present day society is all about information, bacha. When you see any cricket match, so let's say Mahendra Singh Dhoni has scored hundreds in this match, 50s in this match, this is data. If I ask you who is the favorite cricketer, this is data. If I ask you who is the favorite teacher, that's a data. So collecting that data is one thing. Expressing that data and presenting that data in such a form that the people can use it, see it, seek information through it, that is what deals with statistics. So, the word data means information, of course, or a set of given facts in numerical figures. So, for example, like 50 of you said Virat Kohli, that you like Virat Kohli. So, of course, I'll not write down, okay, Mahima likes Virat Kohli, Danish likes Virat Kohli, Kunal likes Virat Kohli, Upasna likes Virat Kohli. I won't say that way, right? How will I say, okay, Virat Kohli, 25 students like him. Mahendra Singh Dhoni, 20 students like him. Rohit Sharma, let's say 10 students like him. Sachin Tendulkar, 50 students like him. So this is how we go through it, right? This is what is data in numerical figure. Getting it? Now, for example, you had a test in your school from 10 marks. So how many marks did you get from that 10? That numerical figure is data. Statistics, it is a science which deals with the collection, presentation, analysis and interpretation of the numerical data. Numerical data we have to collect, we have to present, we have to analyze and interpret to seek information and what we are going through that. In plural, statistics means data. In singular form, statistics is taken as a subject. Statistics, if we talk about as a singular thing, it's a subject. If it's like with a S, it is same as data. Now let's see basically raw data and grouped or ungrouped data. Okay. So see, like for example, 10 students are sitting over here. Okay, I ask one by one how many marks did you get in your exam. So one say 18, the other say 19, 20. So I keep on writing. Okay, that one said 18, the other said 19, other said 16, 18 again, 15, the other said 20, alright, the other said 19, then the other said 10. After that, the other said, for example, 13 and 18. So if I write down, if 10 students are sitting over here, if I ask them one by one how many marks did they get, and they tell me individually, and this is the thing which I have written, this is a raw data. This is what? A raw or ungrouped data. So the data obtained in original form, this is the original form. I will just keep asking you people and I will just keep writing it. This is in the original form. Is called the raw data or the ungrouped data. Now what is group data? We may condense data into classes or groups. Such a presentation is known as group data. For example, I have to see that how many people have scored above average, below average, in which category. So let's say for example I made that 0 to 5, how many people have scored? 5 to 10, how many people have scored? 10 to 15, how many people are there? And 15 to 20, how many people are there? Right? And 20 to 25, how many people are there? Now, if I'm arranging this data now, that okay, let's say 18. So, 18 will come in between 15 and 20. So, 1, 2, 3. So, 3 students have secured in between 15 to 20. Also, 19 lies between 15 to 20. Right? 4, 5, 6, 7. And so 7 students have secured in between 15 to 20. Now this becomes your grouped data. When you arrange the marks in classes, this becomes more presentable. Okay, although this is like a group thing, like we are not sure of in between 15 to 20 how many got 16, 17, 18, 19, that is not specific, but still we have it to analyze because we don't need specific marks. We need how the class is performing on the larger thing, how the population, how the world is performing. So this is how it goes and the difference between group data and ungrouped data. Now presentation of data is very important, right? You might have seen some of the presentation in pie charts. You might have seen some of the presentation in bar graphs, right? When we are comparing same bar graph, when we are in a class, you know, class interval is their histogram presentation. So this is how we are going to do it. So let's see the one thing, presentation of data. Now see, the marks obtained by 10 students and it is written as it is. There are 10 students who have performed in an exam, they got some marks and their marks is written as it is. Now this is raw data, this is ungrouped data, this is known as ungrouped data or raw data. Now the next thing is, now this is the marks obtained by 30 students, this is also ungrouped data. Right, as I can see some of them are securing 10, some of them are getting 92, but it is very hard to read, to understand. This is also raw data. Alright, this is also raw data. Now, the next thing is presentation of data. Okay, the difference between the maximum value and the minimum value of a variate is called range. Now, for example, in this table, I ask you students what is the range. So how you will calculate the range? What is the highest value? In this particular set, I guess 92 is there, 95 is there. So I guess 95 is the highest value. Yes, 95 is the highest value among all these 30. Which one is the lowest value? So lowest value, let's say 10 is the lowest value. So what is the range? If I talk about students, range is highest value minus lowest value, that will give you the range of the data. The highest value minus the lowest value gives you the range of the data. Now this is known as frequency distribution or grouped frequency distribution. So basically this is a part of presentation of data. Now see, one data which we have seen is like this. Right, just the data given over here. The other data that we have is like this. Which one is more presentable? Which one is more appealing to the eyes? Which one is more kind of, we can say that giving us more information is this data. That 10 students, 10 1 mark, right? 20 marks 1 student. 36 marks 3 students, 40 marks 4 students, 53, 56 2, 64, 74, 72 1, 81 and so on. So this is more presentable as it is more readable, right? Now over here, we do not even have to see for upper limit and lower limit as it is clearly visible. The highest value and the lowest value, the range is clearly visible. So this is what is presentation of data, and this numbers, that how many students have secured 50 marks, 3 students. that becomes the frequency. This is known as frequency, that how many times that particular thing is repeating itself becomes the frequency. Now let's see a question, people. This is frequency distribution. You know, blood group of 30 students is given to you and you have to form a frequency distribution table. So the very first thing is you have to make a table. You have to see how many different blood groups are there. So you have to make one column for blood group and the second column is frequency. Now what is frequency, bacha? That how many people are having that blood group. Okay, now we can say there are blood group A, B, O and AB. So 4 blood groups are there. So let's write A, B, O and AB. Now we have to check for the frequency. What does that mean? That how many people have A blood group. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many of them have A blood group? 9 of them have A blood group. How many of them have B blood group? 1, 2, 3, 4, 5, 6. So 6 of them are having B blood group. How many are O blood group, bacha? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many are O blood group? 12. How many are AB? 1, 2 and 3 are AB. Now if we add them, 9 and 16, 15, 12 and 3, 15, 15 and 15, 30, we have included all. So this is what is frequency distribution. This is what is known as frequency distribution, right? You can also write this in numbers and if you want, bacha, you can also write this in tally. What are tally marks? I hope you remember the thing that you have learnt in 8th. Tally marks. How to write 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. How to write 6? 1, 2, 3, 4, 5, 6. How to write 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How to write 3? 1, 2, 3. So you can write down directly as numbers or you can also write them in tally or you can say with the lines. The next thing that we have over here is like this. Now it is showing that the value of pi up to 50 decimal. We know that the value of pi is 3.14, but is it the exact that value that we are taking? No. The exact value that we have is 3.14159265358979 and so on. So the question says, make a frequency distribution of the digits from 0 to 9 after the decimal point. So 0 to 9 after the decimal point. So first of all, the digits, right? Digits and frequency that we are going to talk about. So this is 0, this is for 1, this is for 2, this is for 3, this is for 4, this is for 5, this is for 6, this is for 7, this is for 8 and 9. Okay, so basically we are over here talking about digits. And after digits, we are talking about the frequency. Okay, so what are the digits? From 0 to 9 is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we have to talk about the frequency, that how many times each number is repeating. Let's say if we are taking 1, we are taking 2, we are taking 3 or so on. Alright, let's do it. So 0, when we talk about 0, 0, 0, 0, 0, okay, wait. 1, 5, 9, 2, 6, 5, 3, 7. How many zeros are there? I can only see 1 and 2, right? So the number of zeros that I can see is 2. So the frequency of 0 becomes 2, right? Simple. How many 1 are there? So 1, 2, 3, 4 and 5. So how many 1 are there, bacha? 5 1 are there. How many 3 are there? Let's see. 3 after decimal, okay? So 1, we have 2, 3, 4, 5, 6, 7, 8. So how many 3? So how many 2? Oh wait, have we calculated 1? Yes, we haven't calculated 2. So, okay, wait, 3 are 8. Now let's calculate 2. So, we have 1, we have 2, we have 3, we have 4, we have 5. Okay, so the amount of 2 that we have are 5 and the amount of 3 that we have is 8. And the amount of 1 that we had was also the same. Let's calculate for 4. So, we have 1, 4, 2, 3, 4. Yes, so the amount of 4 is 4. Now calculate for 5. So we have 1, 5, 2, 3, 4, 5. So the number of 5 is also 5. Now let's check for 6. So 6, let's see 1. Then we have 2, 3 and 4. That's it. 4. Now let's check for 7, bacha. So how many 7 are there? 1, we have 2, we have 3 and we have 4. So 4, 7, the number of 8 that we have is 1, 2, 3, 4, 5. That's it. So 5, 8 are there and after that we have to calculate for 9. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So all we have taken and the number of 9 is 8. So this is how we make the frequency distribution from 0 to 9 after the decimal place. Now the next thing is, what are the most and the least frequent occurring? So most frequent occurring means beta the number which is coming most of the time. So I guess this is most frequently occurring. This 9 is also most frequently occurring because both of them are occurring 8 times and the least occurrence is of 0. Right? And the least occurrence is of 0. Great. Now the next one, okay, wait. Okay, so what is the most? And so most is 3 and 9 and the least is 0. I hope this thing is clear with everyone. Right? Now let's move to the next question. The next question says that 30 children were asked about the number of hours they watched TV. So 30 students watched TV and they were asked about the number of hours they have watched. So make a frequency distribution but taking class as 5 to 10 and one of the class as gap as 5. So bacha, how to do? How to do that? First of all, we have to categorize. See, 0 to 5, 5 to 10, 10 to 15, 15 to 20. For that, we need to find the range, which is the lowest number 1, which is the highest number that can be seen over here is 17 or 21. So we have to take up till 25. So the classes that we make is like this. So 0 to 5, 5 to 10, right? 10 to 15, 15 to 20 and 20 to 25. So these are the classes that we are taking. Basically, these are the classes in which we have to include. Now, you might be wondering, ma'am, 5 is here also. 5 is here also. In which particular thing do we have to take the 5 exactly? That if we have to take 5, in which class will it come? In 0 to 5 or 5 to 10? It will always come where it is in the lower limit. Lower limit means in the starting, that is 5. Okay. Now, let's see 0 to 5. How many people are getting 0 to 5? So 1 is between 0 to 5, 2 is between 0 to 5, 3 is between 0 to 5, 5 is not in between 0 to 5, okay? 4 in between 0 to 5, 3 in between 0 to 5, okay? So we have 5, yes, we have 6, we have 7, we have 8, we have 9, we have 10. Okay, so 10 students are there, 10 children are there whose count is between 0 to 5. Okay, next we are talking about 5 to 10 hours. So in 5 to 10, 6 is included, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many in between 5 to 10 hours? 12. How many in between 10 to 15? When we talk about 10 to 15, how many are there? So in between 10 to 15, 1, 2, 3, 4. right? So how many in between 10 to 15? We have 4, okay? I guess 1 8 we have missed, so it will be 13 over here. Okay, so we have 10, 13 and 4, right? Now let's say between 15 to 20 when we talk about. So in between 15 to 20 we have 1 and 2, right? In between 15 to 20 we have 2 and in between 20 to 25 we have 1. All right. Okay, so we have 13, 14, 15 and 15, 15, 30. So this is what we have taken as that. Now, let's talk about, this is the frequency distribution in class intervals. This is in class intervals. What are class intervals? When we arrange the data in some classes. I hope this thing is clear. Okay. Now the question says how many students, how many children watch the television for 15 or more hours. So for 15 or more hours, only 3 of them have watched the television. 15 and more. So more includes even 20 to 25 as well. Now graphical representation of data includes 3 types. You have your bar graph, you have your histogram and your frequency polygon. Let's solve it up. So the very first question is of bar graph. This is how a bar graph looks like. So you have some information on the x-axis, the amount, the frequency on the y-axis, and then you plot rectangular graphs. Now the very first thing is draw a bar graph for these political parties till F. The very first thing that you have to do is take the x-axis. The second thing that you have to take is y-axis. So this is the x-axis, this is the y-axis. Now this is the origin, this is the political party A, this is the political party B. Alright, this is the political party C, this is the political party D, this is the political party E, and this is the political party F. So we have drawn the political parties on the x-axis. Now let's take what scale we can take. So 10, 30, 29, 70. So we can take a scale of 10. So over here 10, 20, 30, 40, 50, 60, 70 and 80. Okay, now let's see how to draw the graph. The very first thing is that we have is 75, 55. So the first party is 75. So let's take the party as 75. 75 means in between 70 and 80. So this is somewhere in between 70 and 80. That becomes your 75. The next is 55. So 55 is in between 50 and 60. That becomes 55. 37 and 29. So 37 is somewhere just below 40. That is 37. 29 is just below 30, bacha. So somewhere here. Then we have 10 and 37. So 10 is like this. This is 10. And after 10 we have 37, quite below of 40. Like this. So this is how we draw a bar graph by using x-axis and y-axis alongside. Okay. So if you want to write down the scale, you can do it. So when you write down the scale, so scale on x-axis, alright, 1 unit is equals to 1 political party, and seats 1 on y-axis, 1 unit is equals to 10 seats. So this is how you do the questions and the answers. I hope this thing is clear with everyone. Right, let's move forward. Which political party has won the maximum seats? So political party A has won the maximum seats. Simple. Now the difference between bar graph and histogram, bacha. So bar graph is formed for the ungrouped data, raw data that we have. Okay, but when we talk about group data or the data with class intervals, this is how the histogram is made. I think that this is absolutely clear with you people. Okay, now let's see, for example, how do we draw a histogram? Let's say data is given to us. Let's, for example, 5 to 10 marks. Okay, let's talk about marks. 5 to 10, 15 people have got the marks. 10 to 15, let's say 20 people got the marks. Then we have 15 to 20, so let's say 10 people got the marks. Then we have 20 to 25, let's say 30 people have got the marks. And when we talk about 25 to 30, let's say 5 students have got the marks. Now, if I have to draw the histogram, because it will be a histogram because the intervals are there, the class intervals are there. So, let's take the x-axis first of all. Okay, this is our x-axis, great, and this is our y-axis. So, we will take x-axis, y-axis, the origin. So, we have 5, 10, 15, 20, 25, 30 and 35. Okay, now these are the marks. Let's take a gap of 5, 10, 15, 20, 25 and 30. So these are what? The marks. These are the class intervals. You can write class intervals, and these are the marks secured by students. Now the next thing is we have to draw the rectangular bars, but with no gap in between. Like 0 to 5, 15 people have got it. So 0 to 5, 5 to 10, 15 people have got it. So 5 to 10, 15 people have got the marks. Great. Now 10 to 15, 20. So 10 to 15 we have 20 people who have got the marks. Now 15 to 20, 10. So 15 to 20 we have 10 students who got the marks. Then we have 30 and 5. So then we have a 30 scale. Okay, and after 30 we have 5. So as you can see, the difference between bar graph and histogram is just the gap. Everything else remain the same. See, 5 to 10 this much, then 10 to 15 this much. Alright. The next thing that we have, students, is frequency polygon. Now what are frequency polygon? It is also one way to express your data, right? To present two or more information in one single. To compare something, we use frequency polygon. Now how do we use it? Let's get started. So over here it is given that the following table gives the distribution of students of two sections according to the marks obtained by them. We have section A students and section B students. Okay. Now over here what do we have? We have to figure it out. Section A students have this many marks, like 0 to 10, 3, 10 to 29. And then section B is that. For frequency polygon, bacha, we have to calculate one more thing before starting, and that one more thing is class mark. Now what is class mark? Upper limit plus lower limit divided by 2. That means 0 plus 10 divided by 2. 10 divided by 2, 5. Basically, class mark is the middle value of class interval. 10 to 20, the middle value is 15. Then we have 25, 35 and 45. Same goes here. We have 5, 15, 25, 35 and 45. So this is the class interval that it goes through. Now we have to make a frequency polygon. So in frequency polygon, bacha, what do? We do not plot the class interval, but we plot the class mark, right? So what we are plotting? We are plotting class marks, right? And the students. Number of students, that is 3, 9, 17, 12, 9 and approximately till 19. So we can use a gap of 3. Okay. So first of all, let's see 5, 10, 15. Okay, let's start from 0. So we have 5, we have 10, we have 15. We are plotting the class mark. Okay. Then we have 25. Okay. No. Okay, we have 5 and 15, right? We have 5, we have 15, we have 25. We have 35, we have 45, okay? 45 and 55 as well. Let's take extra. Okay. Now on y-axis, we are taking students in a gap of 3. So we have 3, we have 6, we have 9, we have 12, we have 15, we have 18 and we have 21. Now let's make a frequency polygon, bacha. How do we make it? See, the very first is 5 and 3. So 5 and 3, let's make a dot. Then we have 15 and 9. 15 and 9, let's make a dot. Then we have 25 and 17. 25 and 17 somewhere below 18, let's make a dot. Then we have 12 and 9. Okay. So then we have 35 as 12, and then we have 45 as 9. Okay, so this is what we guess as our frequency polygon. This is what a frequency polygon looks like. Okay, I hope that this thing is absolutely clear with everyone. Okay, now let's join them with freehand. So this is for section A. This frequency polygon is for section A. Now let's plot it for section B. 5 and 5. So we have 5 and 5 somewhere over here. Then we have 15 and 19. 15 and 19 somewhere here. Then we have 25 and 15. 25 and 15 somewhere here. Then we have 35 and 10. 35 and 10 somewhere here. And then we have 45 and 1. So 45 and 1 lie somewhere there. Okay. So now let's check how we can join it with freehand. So it goes like this, 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 and this. So this is the frequency polygon of section B. Right? So this is how you draw the frequency polygon. Now let's quickly talk about the central tendencies. Okay, now what are central tendencies? 3 central tendencies are there: mean, median and mode. So what is mean? It is basically the average. Sum of observation upon total number of observation means your mean. So for example, these are the number of books that are issued in one single day. Alright, these are the number of books that are issued in one single day. So basically we have to find the average number of books issued per day. So basically sum of observation upon number of observation, that means 105 plus 216 plus 322 plus 167 plus 273 plus 405 plus 346, and this is divided by 1, 2, 3, 4, 5, 6, 7. So this is it. So we have to find the sum of observation. So it is 1834 divided by 7. So simply 1834 bacha divided by 7 gives 262, and this 262 becomes the mean. Simple. Sum of observation divided by number of observation. The next we have is median. Now median means the middlemost value. So the very first thing we have to do is arrange the data in ascending or descending order. If the number of observation is even, so it is n by 2. If the number of observation is odd, it is n plus n by 2 plus 1. So let's see. So the ages of 10 teachers are this. Find the median age. Let's do it. So what are the ages? Let's arrange in ascending order. So I guess the smallest age is 32 itself. After 32, what do we have? After 32, we are having the next age as, let's say, 34. Okay, you can say arrange it in ascending and descending order both. So we have 32, we have 34. After 34, we have 36. Alright, after 36, we have, let's say, 37 is the next. After 37, we are having 40. After 40, we have 44. After 44, we are having 47. Then we have 50 and 53. So the very first thing to check about it is arrange it in ascending order. One thing. Now the next is the number of observation is over here 10. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have missed one, I guess. 54. Okay. So it is 10. Now basically what is the median? Alright, we have to find the median. So basically when the terms are even, when the number of terms are even, so how do we calculate the median? Simply by n by 2th observation plus n by 2 plus 1th observation divided by 2. That means n by 2 is 10 by 2th observation plus 10 by 2 plus 1th observation divided by 2. That means 5th observation plus 6th observation divided by 2. First, second, third, fourth, fifth. 40 plus 44 divided by 2. And that will simply give you 42 as the answer. So what is the median of the data? The median of the data is 42. The last central tendency is mode, and it is the easiest. Mode means which is coming the maximum number of times. That is, So in this data, as we can see that 6 is the number that is coming 4 times. So what will be the mode of this data? 6. As simple as that. Okay. So determine the mode, alright, of the following. The number which is coming at the maximum number of times becomes your mode. So you can comment the answer down. Alright, I hope that the class is clear with everyone. So this is just about statistics. Mean, median and mode is not in CBSE, but again if it is coming in your examination, feel free to study it from here. So I'll see you in the very next class. Till then, take care. Have a great time ahead. Thank you so much everyone. Bye-bye.